homogeneous problem, then the integral of y2 times g over the Wronskian of y1 and y2 dt with a negative sign on it times y1t plus another similar term y1t dt, so there was a parallel mirror term dt y2t solves the non-homogeneous problem. In other words, given a fundamental set for the homogeneous problem, you immediately know a solution for the non-homogeneous problem. Okay. You can get a solution for the non-homogeneous problem using the fundamental set of solutions and the G term, the forcing term. So this should be like, oh, wow, right? Yeah.
Quick question. So the Wronskian is y1 and y2. It doesn't matter if we were like, it's not. We don't swap.
We don't swap them. Yeah.
Yeah. You know what I meant, right?
Yes, I do.
Okay.
Yeah. So it's y1, y2.
Okay.
y1, y2, y1 prime, y2 prime is the term.
Okay.
Awesome.
And those two are added together, right? So
Yeah, it's a sum.
Okay.
So this multiple of y1 plus this multiple of y2 is a solution of n. Okay. And you can sort of see the relation between this and D'Alembert's thinking, right? D'Alembert's thinking was that if you have one solution, then you make a guess that the new solution is going to be some function times the old solution. Here we have two solutions, and we're going to make a guess that the new solution is going to be some function times the first kind plus another function times the second kind. Okay, and see what happens. And it turns out that this is a productive way of thinking. Cancellation occurs. Cancellation occurs just like it did in the previous case. We lose some complexity, and we're able to solve it. Okay. So this is actually pretty cool thinking. So here's the idea. When we played up that idea again, we make a guess that we assume, that the solution of n can be expressed as u1t, y1t plus u2t, y2t. Actually, let me come back here and rewrite that because I'm going to need the whole word. So assume some function times the first time plus some function times the second. Okay. We'll just plug that back in and see what that says about what we need to do to figure out what u1 and u2 are. Okay. So we're hoping that the same sort of thing will happen, right? Because these guys are solutions for the homogeneous problem. Plugging them in ought to somehow result in some cancellation. So as usual, we do some stack work. So yp is this thing. Y, maybe I just said this thing. It's my North Carolina accent coming through. I don't know if I've told this story before, but when I first started teaching as a graduate student, one of the administrators in charge of the teaching came to me and put her hand on my shoulder and she said, "Winston, I have to tell you that a student came to me today and dropped out of your class because he said he could not understand your accent." And I it's like, and the administrator said, and I told the student, I know wants to know, and he doesn't have any accent. But the student insisted, no, he's got this very heavy accent. I can't understand anything that he's saying. And I was like, is it my North Carolina accent? Because I was born in North Carolina. Anyway, so the sort of follow-up to the story is that I had a friend who was teaching biology, and she had some of the students that I had, and she said to her students, and these students were from Korea. She said, I hear that Professor O, or Mr. O, has an accent, and they said to her, yeah, but we're from Korea, so we can understand Anyway, so let's go on. So, actually, it's actually been shown to be true by linguists that if you show a picture, you show a movie of a Chinese person speaking, and you dub it over with an American person's accent, and you do the opposite. You take an American person, dub it over a white person, dub it over with a Chinese person's accent. People will watch it and say they will insist that the first person has an accent and that the second person doesn't. Yeah, it's pretty impressive. Oops, that's why. Okay, so this is two integers. y(v1) prime t y1 t plus u2t y2 prime t plus u2 prime t y2 t. You just use the chain rule, right? Is the chain rule. Right? But at this point, you do something a little bit peculiar. Okay? You assume, let's make an assumption. Let's impose a condition. So let's impose a condition, an additional condition. Namely, that the sum of these terms, u1 prime t plus y1 t plus u2 prime t y2 t is 0. Okay? So we're gonna insist that this be true. Okay. In that case, y double prime is not as complicated as you feared. And you get u1 times y1 double prime plus u1 prime y1 prime plus u2 y2 double prime plus u2 prime y2 prime. Okay, and then you substitute. Okay, and what happens is you end up with u1t times y1 double prime t plus p of t y1 prime t plus qt y1 t. I'm going to suppress the t's to make it cleaner. You get y2 times y2 double prime plus py2 plus qy2 plus y1 prime, u1 prime y1 prime plus u2 prime y2 prime equals g. And that, which you hope for, comes to happen, right? Right? Cancellation, right? y1 is the solution of the homogeneous problem. y2 is the solution of the homogeneous problem. Right? And so you end up with just this thing at the bottom here. I was born in Winston-Salem, North Carolina. That's how I got my name. So the problem is reduced to this y1 u1 prime plus y2 u2 prime equals 0, right? That's the condition that we imposed, right? y1 prime u1 prime plus y2 prime u2 prime equals g. Right? We have to solve, we want to figure out what u1 and u2 will be. Right? The problem of determining u1 and u2 changes to this problem. Right? u1 and u2 need to satisfy this. We can find u1 and u2 that satisfy this, we're good. Right? But you notice that this is a set, a set of simultaneous equations for u1 prime and u2 prime. Right? Right? This is y1, y2, y1 prime, y2 prime, times the vector u1 prime, u2 prime equals 0g. In matrix form. And is this matrix invertible? Yes, because the determinant is non-zero, because these guys are the fundamental set of solutions. They're linearly independent. We know that the Wronskian is non-zero. Like the determinant of this is the Wronskian, which is non-zero, because we know this has the fundamental set of solutions. Right? So the only thing we need to do is take the inverse. So multiply by the inverse. Right? Well, what's the inverse? That's 1 over the Wronskian times the adjoint matrix. Right? So it's y2 prime negative y2 negative y1 prime y1. Multiplied by the adjoint and then the inverse on both sides. Right? And you end up with u1 prime, u2 prime is 1 over the Wronskian times this thing, is the adjoint matrix. So G. In other words, it is 1 over the Wronskian negative y2 times g, y1 times g. Okay, right. In other words, u1 prime is negative y2g over the Wronskian. u2 prime is negative y1 times g over the Wronskian. So y, which was u1 y1 plus u2 y2, is then expressible as the antiderivative of negative y2g over w times y1 plus the antiderivative, I'm sorry, this should be plus, times the antiderivative of y1g over the Wronskian 22. Right? Which is what we said. So this is great, right? Given any second order linear non-homogeneous problem, if you can solve the homogeneous problem, then this gives you a way of getting a solution to the non-homogeneous problem.